Good afternoon to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering. And today my content is GTU question paper solution of the subject of vector calculus and linear algebra of September 2009. So up to question number 3b we already see. So let's see next topic. Question 3c. Show that W is equal to 9 to 7 is a linear combination of the vectors U is equal to 1 2 minus 1 and V is equal to 6 4 2 in R3. So in order W to be a linear combination of U and V, there must be scalar A and B such that AU plus BV that is equal to W. So here we want to check that the given these two vectors are linear combination of this vector 9 to 7, is it a linear combination of this two vector 1 2 minus 1 and V is equal to 6 4 2 or not. So let's see. For that we have to take linear combination AU plus BV that is equal to W. So A into 1 2 minus 1 plus B into 6 4 2 that is equal to 9 to 7. From this equation we will get this two equation A plus 6B that is equal to 9, 2A plus 4B that is equal to 2 and minus A plus 2B that is equal to 7. So from these three equations we get the augmented matrix. From that we get augmented matrix 1 6 9. First row is 1 6 9, that is coming from the first equation. The coefficient of A is 1, the coefficient of B is 6 and this is the constant term. 2A plus 4B is equal to 2. So the coefficient of A is 2, the coefficient of B is 4 and this is equal to 2 and minus A plus 2B that is equal to 7. So coming from the third equation we will get minus 1 to 7. Okay. Now we have to convert the given matrix into a row echelon form, right? What is row echelon form? That we know that the leading entry, what is leading entry or pivot? The first non-zero element in any row, that is called leading entry of that row, and below that leading entry all the elements should be the 0. That is the first condition. The second condition is whenever we are going from above to below, the leading entry is going from left to right. Okay. And the third condition is if there is any 0 row, it should be a bottom of the matrix. So if these three conditions are satisfied, then we can say that the given matrix is in row echelon form. So here we have to convert. Now we have to convert the given matrix into a row echelon form. So here we have to do some process. Here is the some processes. We have to multiply first row with minus 2 and add into the second row, and we have to multiply first row with 1 and add into the third row. Okay. So first row with multiply minus 2. So you can see that 2 minus 2 that is 0, 4 minus 12 that is minus 8 and 2 minus 18 that is minus 16. So 0 minus 8 minus 16. Then first row we multiply with 1 and add into the third row. We get 0 8 and 16, right? So here 0 8 16. Okay. Now the first row is as it is. The second row, now the second row is we have to multiply second row with 1 and add into the third row, because you can see the second and third row are almost same, just we have to multiply minus 1 with second row, we will get third row. So that's why whenever we multiply second row with 1 and add into the third row become 0. So now you can see that this is your augmented row echelon form matrix. From that matrix we can easily solve the equations. So x plus 6y that is equal to 9 is coming from the first row, the first equation. In the second row Coming from the second row, we get this equation minus 8y is equal to minus 16. So y is equal to 2, x is equal to 9, minus 12, that is equal to minus 3. So definitely we will get the value of x and y. So hence w is a linear combination of u and v. If we cannot find x and y, then w is not a linear combination of u and v, but here we can find the value of x and y, so w is a linear combination of u and v. This is the next question, or question 3a. Find basis for the row space and column space of A, and this is a 4 cross 6 matrix, right? There are 4 number of row and 6 number of column. So the first row is 1 minus 3 4 minus 2 5 4. The second row is 2 minus 6 9 minus 1 8 2. The third row is 2 minus 6 9 minus 1 9 7. And the fourth row is minus 1 3 minus 4 2 minus 5 minus 4. So this question asking 5 marks. First we want to find the basis for the row space and column space of the given matrix, right? So here is a matrix, the same matrix. First of all, we have to convert again. We have to convert this matrix into a row echelon form, right? So this is our leading entry. Below that leading entry, we want make 0 here, right, in the first column. So that's why we have to multiply first row with minus 2 and add into the second row. That is our first process. So here is the first process. We have to multiply first row with minus 2 and add into the second row. So we get, you can see from this matrix, 2 minus 2 0, minus 6 plus 6, that is also 0, 9 minus 8, that is 1, minus 1 plus 4, right, that is 3, 8 minus 10, that is minus 2, and 2 minus 8, that is minus 6. So here is the answer. You can see 0 0 1 3 minus 2 minus 6, right? So here is the first process that we understand, that first row will multiply with minus 2 and add into the second row. The next process is first we have to multiply first row with minus 2 and add into the third row. So you can see, understand from this matrix, 2 minus 2 0, minus 6 plus 6, that is also 0, 9 minus 8, that is 1, minus 1 plus 4, that is 3, 9 minus 10, that is minus 1, and 7 minus 8, that is also minus 1. So here is the third row, becomes 0 0 1 3 minus 1 minus 1, correct. Next we have to multiply first row with 1 and add into the fourth row. Okay, you have to multiply the first row with 1 and add into the fourth row. So just add this two row, 1 minus 1 0, minus 3 plus 3, that is also 0, 4 minus 4 0, minus 2 plus 2, that is 0, 5 minus 5, and 4 minus 4. So the last row become 0 row, right? The last row become 0 row. The first 3 non-zero rows, you can see the first 3 are non-zero rows, okay, of the last matrix, form a basis. And the first 3 are non-zero row, the last row is a 0 row, right? So whenever we find the basis for the row space, we have to consider the non-zero row from the given matrix, right, of the row echelon form matrix. So there are only 3 non-zero rows. So these 3 row vectors are exactly the basis vector for the row space of A, right? What is the first row? 1 minus 3 4 minus 2 5 4, 1 minus 3 4 minus 2 5 4. The second row is 0 0 1 3 minus 2 minus 6, and the third row is 0 0 0 0 1 5. So these 3 vectors are exactly the basis for the row space of A. Okay, from the last matrix we observe that the pivots means leading entry, are in the column first 3 and 5. You can see from this row echelon form matrix, in which column we have leading entry. The first column we have leading entry, second column does not have any leading entry, right? the third column we have leading entry, and the fifth column we have leading entry, right? So whenever we find the column space basis for the column space, we have to consider the first, third and fifth column of the given matrix A, because for the given matrix A we have to convert the row echelon form matrix. From that row echelon form matrix you can see the first, third and fifth column we have leading entry. So corresponding to first, third and fifth column we have to take matrix A. You can see first, third and fifth column, these three column vectors are exactly the basis vector for the column space of A. So 1 2 2 minus 1, 4 9 9 minus 4 and 5 8 9 minus 5, these three column vectors are exactly the basis for the column space of A. So here is the explanation. From the last matrix we observe that the pivots, that means leading entries, are in the column 1 3 and 5, hence the column 1 3 and 5 of A form a basis for the column space of A. Thus basis for column space of A, that is equal to 1 2 2 minus 1, 4 9 9 minus 4, 5 8 9 minus 5. Okay. Next question, question 3b. Let S is equal to V1 V2 V3 be the basis for R3, where V1 is equal to 1 2 1, V2 is equal to 2 9 0 and V3 is equal to 3 3 4. The question is, find the coordinate vector of V, that is equal to 5 minus 1 9 with respect to S. Okay, and find the vector V in R3 whose coordinate vector with respect to the S in minus 1 3 2. Okay, so let's try to solve this question. This question asking 5 marks in this question paper. To find the coordinate vector V with respect to the basis S, we write V is equal to AV1 plus BV2 and plus CV3, and we have to find A, B, C, right? Such scalars, that is exactly the coordinate vector of the vector V. So 5 minus 1 9, that is equal to A into 1 2 1 plus B into 2 9 0 plus C into 3 3 4. So 5 minus 1 9, that is equal to A plus 2B plus 3C. The second equation is 2A plus 9B plus 3C, and the third equation is A plus 4C. So comparing this two part, we will get A plus 2B plus 3C, that is equal to 5, 2A plus 9B plus 3C, that is equal to minus 1, and A plus 4C is equal to 9, right? So we have to solve these three equations using the matrix. So from these three equations we can write down the augmented matrix. You can see from first matrix, first equation, we get the first row 1 2 3 5, 1 2 3 5. From the second equation 2 9 3 minus 1, 2 9 3 minus 1, and from the third equations the coefficient of A, B, C, that is 1 0 4. So 1 0 4 and 9, right? Again we have to convert this augmented matrix into a row echelon form. So that's why we have to multiply first row with minus 2 and add into the second row. That is our first process. So the first row is as it is. The second row become 2 minus 2 0, 9 minus 4 5, 3 minus 6, that is minus 3, and minus 1 minus 10, that is minus 11. Then we have to multiply first row with minus 1 and add into the third row. So we get 1 minus 1 0, 0 minus 2, that is minus 2, 4 minus 3, that is 1, and 9 minus 5, that is 4. Okay, so next process, we have to multiply third row with 2 and add into the second row. So that's why we make 1 in here, right? We want to leading entry 1, so that's why we multiply third row with 2 and add into the second row. 1 2 3 5. So the second row become now 0 1 minus 1 1 minus minus 3 plus 2, that is minus 1, and minus 11 plus 8, that is minus 3, right? So second row become now 0 1 minus 1 3 minus 3, and the third row is 0 minus 2 1 4. Now this is our leading entry. Below that leading entry we want 0. Okay, so that's why now next process is we have to multiply second row with 2 and add into the third row. So 1 2 3 5, the first row is as it is, 0 1 minus 1 3, the second row is also as it is, and the third row become 0 0 minus 1 minus 2, right? 0 0 minus 1 minus 2. Now this matrix into a row echelon form. From this matrix we can write down the equations, that is a plus 2b plus 3c is equal to 5, b minus c, that is equal to minus 3, and minus c is equal to minus 2. Okay, so c is equal to 2, b is equal to minus 1, and a is equal to 1. Solving these three equations, c is equal to 2, okay, because minus c is equal to minus 2, so c is equal to 2. Put that value of c is equal to 2 in this equation, we get b is equal to minus 3 plus 2, that is b is equal to minus 1, and a plus 2b plus 3c is equal to 5. So put the value of b and c in this equation, we get a is equal to 1, right? So the coordinate vector of v with respect to the given basis s is 1 minus 1 2. Okay, using the definition of coordinate vector, we obtain v is equal to minus 1 into v1, because see this is our coordinate vector. The next question is find the vector